We often come across a concept that any number having power 0 is always 1. So what's the reason behind this concept? This thing can be explained by two ways. The first way is by seeing a mathematical pattern. Like for instance, 2 having a power of 0 and I am unaware of the result. But let's consider 2 having a power of 1 is 2. 2 having a power of 2 is 4. 2 having a power of 3 is 8. 2 having a power of 4 is 16. 2 having a power of 5 is 32. So you see that every time I am progressing, the previous number is being doubled to get the next number. So the double of 2 is 4, the double of 4 is 8, the double of 8 is 16, and likewise this will be followed with the next numbers. So 2 having a power of 6 is 64, and this goes on. But for one instant, if I think in the reverse order, 64 is converting into 32, 32 is converting into 16, 16 is converting into 8, 8 is converting into 4, and 4 is then converting into 2. So the logic behind this is if I go back, it is being divided by 2, or in other words, it can be said that it is being halved. So every time I'm going back, it is being halved, or you can say it is being divided by 2. So the if 2 gets divided by 2, ultimately I get the result 1 over here. So you see that by a simple mathematical pattern we are able to drive that 2 having a power of 0 is 1. Likewise, it will also be followed under any number, like for instance 3 having a power of 0. We are unaware of the result right now. So 3 having a power of 1 is 3. 3 having a power of 2 is 9. 3 having a power of 3 is 27. 3 having a power of 4 is 81, and this goes on. So you see that if we are moving like this, so every time you are moving downwards, like you are moving in this direction, so it is being multiplied by 3. But what happens if I move in the reverse direction? If I move from this to this, from this to this point, and from this to this point, and ultimately from this to this, we see that it is being divided by 3. Every time you move in this direction, it is being divided by 3. So finally, when 3 gets divided by 3, the result which I'll get is 1. It happens with every single number. So what do I mean by that? Which means that if I have 4, it will progress with a multiple of 4, and when we go back, it will be divided by 4 every single time, and that's the reason every single number having power 0 will always give you a 1. But there's one more side of the story which needs to be considered. Like for instance, I have x having a power of 0. Now obviously I can just multiply it with x and move forward, and then divide it by x to finally get a 1. But there's one more way to explain this concept, and that is done in this way. Like I can just take this 0 as 1 minus 1, and then by a simple rule of indices, I can simply break it down like this. When the bases are same, the powers are added, so these two steps are identical. So the thing is, now I can just take this thing in the denominator. So that means x to the power of 1 and x to the power of 1. So we have the like terms. The numerator and the denominator have the like terms, so they just cancel out, and we ultimately have the value of 1, which means x to the power of 0 is equal to 1. So this was one of the methods which can be used to just prove this statement, and this is then again one of the methods as well.